Is that stupid black cat out of the way finally? The midnight is not here. Midnight won't bother you anymore. I can just pet you, and you can purr all you want. Okay, you can stop purring now so we can get to work. Okay. Last problem, the facility design problem. We haven't talked about it in a while, and it's not on your textbook, so I thought I'd throw the basic stuff back up here. It's a docking facility. They have two docks. Each dock can unload one ship per day. If they can't unload the ship, they got to pay $10,000. Not the ship, the docking facility has to pay $10,000 per ship per day. They can build a new one for $5 million. That's just kind of across the board what it will cost, $5 million. And so we got to look at what's the distribution of the cost now, and can we financially justify adding one or more docks? And will this change? We look at the simulation model based on essentially we do a 1 year simulation, what we started with in the day before. So here is the problem, as we've seen. So remember the one trial, this all the way over here. This is a single simulation trial because we're doing 365 days, and there's the ships from the previous year. So there's two docks. You pay $10,000 per ship sitting there, and we start with two ships. And we say, every time we hit F9, that changes a lot from 3.6 to 5.9 to 6.1 to 3.2, $4 million. Changes a lot. And that's per year. And then we're just kind of curious the maximum number of ships waiting at any given time. So at one point there were 8 ships waiting. So over here, the multi-trials is a single trial is 365 days. This is 365 days. So out of these, how many did we do? 500 simulations. There were times, one time there's 20 ships waiting. But each of these is simulating essentially 500 different years. So same question, what's the distribution of that charges? Same kind of statistics. Again, like the last one, I'm not going to have this record me typing all those formulas in. You should look back at your other examples, and we want the 5-number summary, mean, standard deviation, interquartile range. You might want to put a margin of error on there to see if 500 is enough to give you a good enough estimate on the cost. So I'll pause it, I'll put mine in, you go ahead and put yours in. Looks pretty good to me. Thank you. I appreciate your vote of confidence, Stat. I did the statistics for both the cost and the number of ships waiting. Although the number of ships waiting itself might not be as important to our decision as the cost, it is interesting to look at it that out of 500 random simulations, a worst case had 26 ships. The cost, and that associates the $12.5 million cost for making ships wait. So there's quite a range there. It is interesting though to note that with the 5-number summary, 75% of the time we're essentially below $5.4 million. And every time I hit F9, I get a new set of 500 trials, and that's still staying in the low. That's 5.1, 5 million, 5 million, 5 million, 5.2, 5. So that's staying pretty much between 5 million and 5.5 million. So that's probably pretty stable. Speaking of stable, we can go on and look on the mean. This is an estimate for the mean, saying $4.5 million and about $130,000 margin of error. So we're pretty safe saying that the average cost per year of making ships wait is a little under $5 million. So the original question, is it worth $5 million net present value to build a new dock? This wouldn't go away. The question becomes, how much would we save? So now we get to go over, and this is where the simulation kind of gets fun, because we have our single trial, our multiple trials, and our statistical analysis. I'm going to just paste the values, and I'll paste the formats too. This is now. So what if I pay $5 million and now I have 3 docks instead of 2? This is why we call it what if analysis. Do a few trials. Oh, that was very low. There we go. This is looking better. So I hit a few F9s. I'm clearly under $1 million largely. If we look at the 5-number summary, 75% of the time I'm below 900,000. So even if we said it's still going to cost me $1 million, because this would be unusual, this is very high out of 500 trials. If we think it's going to cost me $1 million a year, well, that was $4.5 million a year. I'm saving $3.5 million a year. I still pay for the dock in less than 2 years. So it looks like certainly it is worth adding one more dock. Is it worth adding for another $5 million another dock? Let it catch up. I hit F9 a few times. There's a lot of calculations going on. Okay, I think it caught up. But now my max is less than $400,000. My mean is about $200,000. So I'm saving over $4 million a year, even with these margin of errors. I'm easily saving $4 million a year. It costs $10 million to build 2 docks, but it's saving $4 million a year. I've paid for them both in 3 years. So it's hard to project 3 years out, but if my demand patterns stay consistent for the next 3 years, yeah, it's worth building 2 of them, because it'll pay for itself. Obviously, you can go too far. Let's see if 5 would be too far. So if I built 3 docks, went from 2 docks to 5, I added 3 more docks. That's $15 million in net present value. There'd be a lot of idle. If you go down 500 trials, I never had more than 2 ships waiting. So those docks, by the way, would be idle a lot of the time. So keep that in mind. But according to this, I'm still saving pretty much now everything. 75% of the time I have 0 demurrage charge. I'd average about $1,000 a year on demurrage charges, and I'd pay $15 million, so I'd be saving almost the entire $4.5 million. 4 years would pay for itself, but it's really getting kind of silly because now I'm probably going to have so much idle time in the dock that it's going to get kind of silly. Maybe not. What we haven't done again here is a histogram. There are these really high years. Let's see how frequent those are. So my min is, have I ever gotten below 1.5 million? Doesn't, oh, there's a 1.2. So I'm going to go down to a million. I'm going to go by millions. And then I'm going to do the same kind of histogram I did before. So remember, the bins are the upper end. So if I'm going to start with millions and go by 1 million up to, then I'm going to go 2 million. That's the upper end. And I think 13 million. I don't think this has ever been above 13 million. Let's hit a few more and let it catch up. Oh, it is cracking 13 million. So I'm going to go up another million here. And frequency. Remember how the frequency command works? It's an array command. Select all of it, all the output, type in the word frequency. Where's your data? My data is in column R, and my bins are right here. you're ever worried that on the high end you missed one or missed a few, you can do that, and I should get 500 because it's 500 observations. Now before I make the histogram this time, I want to get the labels already in there. I'm going to go by thousands again. So my first class is 1 million to 2 million. Then 2 million to 3 million, 3 million to 4 million. I'm going to pause it while I type those in. You can type your... Okay, I've got all my labels typed in. One thing I want to show you real quick, if you're working with small data, and let's say your first class was going to literally be 1 through 9, or even 1 through 10. Well, if I do that, the computer thinks I typed in January 10th. And I certainly didn't mean to type in January 10th. It can't interpret 1000-2000 as a date. So if you run into that situation, put the comma on there to force it to not try to make it a date, and you'll be fine. But watch out for that. I've seen people, they're going from 2 to 15, and it thinks it's February 15th. You got to put in the comma 2 to 15, and then it knows that it's not a date. It's just a label. So here are my class labels, here are my frequencies. So I'm going to insert the bar chart. Right away, select data, and put in my labels. Actually, my labels start there. One more. Merge charges in thousands. Get rid of my spaces. Get more entertaining colors. And we see that pretty much this year, below $1 million or below $2 million doesn't seem to happen. So if it costs you $5 million to build a dock, you're going to be saving some money. And as we mentioned in the previous one, the advantage of doing the histogram this way is that the histogram is tied directly into the simulation data. So you do an F9 and get new simulation data, you get a new histogram. The pivot table approach in the first one just doesn't do that. So it's not that one's better or worse, it's whatever you think works best for you. So now I haven't done this one step by step. Look over the trivial training problem. I'm going to have a complete solution put out there all the way through the statistics, and then start working on the 2 assigned problems that you want to do for the simulation unit. Office hours are coming. You can contact me for individualized, one-on-one office hour things. So get working on that. Send emails, or if you have questions, put questions on the A group Google group, and good luck.